Hi everyone. Let's go ahead and see how you can implement RAG with Langchain agent. As you know that we are using here Langchain agent version 1. Recently Langchain has launched its latest library which they are calling as Langchain version 1. Currently that is available with the pre-release, so we will be using Langchain pre-release version, and then we will be seeing that how Langchain implement agent. So this is what its architecture look like. Earlier, we used to use this agent with the LangGraph, and we used to extract, basically we used to import this agent from the LangGraph.prebuilt import create react agent. But now, going forward, as we use LangChain version 1, we will be able to use this agent from the LangChain directly. So we can import it from langchain.agents import create agent. All right, as I have already told you in the previous lesson where we have implemented semantic search, we used their ChromaDB RAG kind of the system, basically like a foundational RAG system, where we had downloaded a research paper from the internet about large language model, and thereafter we had ingested that data into our ChromaDB. We had used there the PyPDF loader, and thereafter through the chunking, then we had ingested that data into the ChromaDB. And then we had tested that using our vector store retrieval as well. And then finally, we had implemented their vector store.similarity search. We had seen various ways to retrieve the data. And all these retrieval was done manually. Now, in this lesson, I'll be showing you how you can retrieve all those data points using the agent itself. Previously, we had used the Ollama embedding. This time, we will also use the same kind of embedding. Always do remember whatever, whatever setting you use to ingest your data, the same kind of setting you have to use to retrieve your data. So previously, in last lesson where we had gone through the semantic search, we had used there the Ollama embedding, if you remember. We used there the Ollama embedding. Let me just show you quickly. Here it is. So this time we have to also use the Ollama embedding. As usual, I have been telling you that the code for this particular course is available at my GitHub repository, Lakshmi Merit. So you can get it from the Lakshmi Merit Langchain V1 projects. So currently, this is the second project we are working on, RAG with the Langchain agents. As I make more projects, all these project code will be available here itself. Now going forward, let's go ahead and first of all create the LangSmith API key so that we can monitor our agent working in the LangSmith itself. LangSmith is observability tool provided by the LangChain. So we are going to call our LangSmith. As they say that LangSmith is unified observability and evaluation platform. So you need to click on the LangSmith. Thereafter, you have to sign up here. I already have account, so it is just going to sign up here directly using my Google. If you don't have, just sign up. And thereafter, you need to click on this setting. And then you will see here API key. Create a new API key. I'm just going to create here agents and then select my personal token and then going to select default workspace. That is going to be the mine workspace here. And then I just simply click on the create API. And then you need to copy it. And thereafter, you need to create .env file here. So basically this .env file. Currently, this .env file is not syncing with the git ignore. So you have to create it. Otherwise, let me just delete that .env from here so that we can track it. So I'm just going to delete this. Now I should be able to track this .env. As you can see here, this .env is now getting tracked. So I will upload this. Obviously, this key later on I will deactivate. Thereafter, I'm going to put my key here. So this is the latest key for the LangChain API key. And these things you have to provide there. So I'm just going to provide here agents. So this is going to be my LangChain project name. All right, so that is going to be the agent. That's all I have to do. Now all the setting is done here. Let's go ahead and install our LangChain library. So at the recording of this video, at the time of recording this video, currently LangChain version 1 is available in the alpha mode. So to install that pre-release version, you have to use this particular command. Thereafter, let's say after some time, once it becomes stable, then you can use this particular command to install your Langchain. So for now, we will use this particular command. Let's go ahead and copy this whole command, open your terminal. So I'm just going to open my terminal here, and then I'm just going to simply provide that pip install pre-release. So this says that the pre-release Langchain Ollama, Langchain Chroma, Langchain Core, and the Langchain community. All these things are going to be installed. As you see, everything is installed here. Once everything is installed, now it is time to get started with our agent. So first I import all the Python necessary library here. As you know, Langchain core.tools, we import here tool so that we can make our retriever tool to retrieve our data from the ChromaDB. And thereafter, as I told you there, I'm going to import create agent from the langchain.agent. As you press control on keyboard and then click on this agent, then you can see here that these are the things which is available there currently, like the agent state, tool node, and the create agent. All right. So I import this create agent. Thereafter, in the Langchain Ollama, I import chat Ollama and the Ollama embedding. I already have my Ollama setup here done. So this is completely up and running. If you are a beginner with the Ollama, then you can come to my YouTube channel here and then go into the playlist. Here I have Ollama getting started videos. You can find out that from the local LM tutorial. Let's come back here. Thereafter, what I do here, then I import the Chroma. So we have to create our vector store, but data ingestion was already done here. So we will just create a connection with our vector store, and then we will connect our vector store with this particular collection here. And then we are going to load our environment variable, which is available here. That's all you have to do. Let's go ahead and write further code. So for further code, we also need to create our LLM here. We are going to use our Qwen3 model here. So this is one of the latest thinking model from the Alibaba. So the model equal to the Qwen3, and this is where my Ollama is running currently. And the temperature, I'm going to use here default temperature. In fact, let's go ahead and remove all these, or you can just use 0.1 so that there could be a little bit variation. Thereafter, we are going to create our Ollama embedding. So this is the same setting which we had done previously. As you see here, you have to make sure that you use same kind of the settings which you had used to ingest your data. Thereafter, I create my Chroma vector store. As you see here, we are not creating any fresh vector store, but we are connecting with our previously ingested data vector store. So the PDF collection name earlier, if you remember that, we had a collection name as the PDF collection. Embedding function is the same embedding function, and the persistent directory is changing. So with this respect, you will notice here that this ChromaDB was this one, but in this directory respect, it is going to be the parent directory and then 01 semantic search. So as you see here, it goes to the parent directory, then the 01 semantic search, and then the ChromaDB. Now with this, we are connected with our VectorDB, where we already have ingested our data. That's all you have to do here. Let's go ahead and set the temperature here 0, or you can just remove this temperature at all. Then we can just find out the default temperature. That's all you have to do. Let's go ahead and run this. Now, as we run it, you can see it here. Every setup has been done here. If you want to test your LLM, you can just simply test your LLM as well here. Let me just delete this. You can just write here LM dot invoke. Then you can just ask here hello. This should be able to give you some, the output. Basically, this should be giving you the output. Yes, it says that hello, I respond, etc., etc., and etc. All the output. All right. So all the basic setup is done. Let's go ahead and create our, the vector store first of all. In fact, vector store is created. Let's go ahead and verify our vector store. So what we will do here, we are going to first find out the how many documents are there in this particular vector store. So I'm just going to run this. Then I find that there are 593 documents. If you remember previously when we ingested that data in our vector store, we had ingested 593 document itself. Now this says that our connection is successful with the vector store. There are many other ways to test that. Let's go ahead and see if we can retrieve the document as well. So we are going to use here vector store.similarity search with our test query, like the methodology. This is just a test query. Don't worry about anything else. Then we are just going to run this. We should be able to get some output here. As you see here that outputs are coming here, that means it is perfectly working fine. All right. Thereafter, we are going to create here a retriever tool. So now let me just take you again here at the top of this lesson, and then I'll explain you. This is our agent. So this agent is like the LLM itself, which is the Qwen3 in our case. Now this agent needs some kind of the tool here. And the tool we are going to provide as the retriever tool. So the retriever tool is going to retrieve the document from the ChromaDB vector space. So we have already connected our vector store with the previously ChromaDB store. Now we need to define our tool here, and we have already imported our tool. So basically we will be using here tool decorator to create a method that is going to be the retrieve context method. So what I do here that I'm going to write here @tool. So basically this says that this method is going to work as a tool for the Langchain agent. And then the response format, this is just content and the artifact. This is going to be used just for the metadata. Thereafter, the query is going to come to this retrieve context method. And then this is going to first print that this is a particular query which I'm going to search. Basically, agent will print this, that this is being performed currently. Thereafter, it is going to find out the relevant document. So the vector store.similarity search, this we have already seen previously. It is going to be something like that itself. And then format for the LLM. So in this case, what happened here that once you get all the document, as you see here previously, we had seen all these documents, which these document comes here. Those documents are having there the document, as you see here, these are going to have some metadata, and in that they are also going to have there the content, right? The page content, etc. Let me just see that if we have a document. Doesn't seems like we have document. Anyway, so we are going to first get the metadata, and out of the metadata we are going to get the page so that we can know that from which particular page this particular data is coming out, and thereafter we are going to get here the whole content, right? The whole page content. So to verify that what data are coming here, let me just show you at the Langsmith. As I had already shown you that we had created this API and we had loaded that using .env. Now you need to come here, go into your tracing projects. Now we should be able to see our agents here. Let me just see that. Let's refresh this. Seems like agent is not called yet. That is why we are not. Yeah, here it is. All right. So agent is there. Now we can see here the agent is there, but agent was not called. That is why we are seeing only one output here that we had used for our chat Ollama testing. Let's come back here again. So what we can do here that as we see here in the result, we can check this result and then I can show you what I'm talking about here. In the result, you will notice all these documents are actually extracted. In this document, you have ID here. Thereafter, you have a metadata. And then along with this metadata, you have here a page number. And as you scroll it here, you will also see there the page content. So this page content is actual page data here. All right. So that's what we are doing there, what you see here. So we are actually joining the page number and also the actual content, and then we are making it as a single content. And then we will return it to our LM just to know that our LM have all these context for the answer. Once you have that, basically once you have your retrieval tool, thereafter what we can do, we can now create our agent here. So what we do, we are going to create our agent. So before creating our agent, we have to also provide a tool to our agent, as you see here. So agent need to be connected with the tool itself. All right. So we create our tool. We create a list of tool. We have only one tool, that is here retrieve context. So that is why we are having here only one tool. Then what we do here, we create here a prompt for our agent. You are a research assistant with the document retriever tool, and the tool is this one. Always use the tool to find the relevant information before answering. Cite page number and be thorough. All right, so this is going to be the system prompt for our agent. All right, once you have that, thereafter, we create our agent here. All right, so the agent is going to be created here. In fact, let's go ahead and do that in the another cell. So I'm just gonna delete this part from here. So as you see here, this agent is now getting created. So we already have our prompt here. We pass this prompt here, and the tool is already there. And the LLM, if you notice that, we had already created using our chat Ollama. So this particular. Now for the agent, we have every necessary things here. So in this create agent, we pass our LLM, we pass the tool, and we also pass here a system prompt. Now we have our RAG agent. Once you have your RAG agent, you can print the graph of your RAG agent. So you can just simply write here RAG underscore agent. That's all you have to do here. Seems like we did not run this particular cell. Let's go ahead and run that cell and thereafter run this cell. So now you have your agent here. This agent is having tool here which is connected with this. So you send a message to your agent. Agent decide that whether it need to use the tool or not. But in our system message, we have told our agent that always use a tool. So it is always going to use a tool to retrieve the text data. All right. So it retrieves the data and thereafter it answer based on the retrieved data. All right. So this is how you create your RAG agent. Let's go ahead and test our RAG agent with some sample prompt. What I'm going to do here, I'm going to invoke my RAG agent with some message. So you need to pass your message with something like this, where you have to pass the messages and then you need to pass here a message. So what are the main methods mentioned in this research paper? I just execute this. As you execute this, you will notice here that it is searching, right? What are the main methods mentioned in this paper? So from where these messages are coming? These messages are coming from this tool itself. As you come here and see the tool implementation, so in the tool implementation, you have this print statement, and thereafter you have this print statement as well, which says that how many relevant documents are found there. So now you will notice here that these two print statements are printed here basically. So this says that, okay, four relevant documents are found. Let's go ahead and print this response. Now, as I print this response, I can see here that there are the four relevant document. As you copy this whole thing from here, let me just copy this whole response basically, copy this complete cell output, and then I come here and then the paste here in my note. You will notice here couple of things. One, there is the messages. In the messages, in a human message, my first message come here, and after that you will notice there is the tool message. So after my first message, the AI message happens here. So AI thinks, and after thinking some time, it find out that it need to call a tool. Then it calls here a tool. All right. So in the tool, it passes all these data, content, etc. So basically, from the tool, actually, these things are coming out of the tool, and what is passed in the tool, so that you can find out here in the AI message. As you see in the AI message, you will find out here somewhere that it has called a tool. All right, let me just see that somewhere. Yeah, here it is, the tool call. So it says that it need to call a tool here, and the name of the tool is retrieve context, and it is going to call a tool with this particular query. After calling the tool, then the tool is executed, and then tool is returning all these answer here. So basically, tool is returning the dog here. All right, our retrieved document. Thereafter, finally, once tool returns all these retrieved document, then finally that is passed to our LM, and then finally LM produces this final answer here. As you see here, it is thinking here. All right, maybe I can find out our AI message should start somewhere from here. That is the page content. Yeah, here it is. All right, as you see here, this is our AI message. That is the final answer for our from our LLM. That is final answer coming. Let's go ahead and trace all these data at the Langsmith. You can come here at the project. Here at the LangGraph, you will see all the execution which has happened with the agent. So first of all, your agent gets your query, and the query was what are the main methods mentioned in this paper. and based on that, it produces the AI output here. And then it says that I need to call a retrieve context tool. Thereafter, the prompt preparation has happened and all these things happened. And then the retrieve context was called here. All right. Once retrieved context was called, then it returns here all these documents here. As you see, it is returning page 103, and then this is the answer. Then it is returning here page 4, and then this is the context in that page 4. Page 95 is coming, and then the page 83 is coming. All these data is coming from your tool, that is the retrieve context. And then that data is passed to the agent. Now, once this data goes to the agent, and then agent again uses that data to produce the final answer. Now, the agent is writing this final answer based on the retrieved data. And thereafter, it again checks that whether it need to call the tool or not. Then it finally decides that no, it has got all the answer. Now it need to end this particular connection. So here it says that it goes to the end tool. Let's go ahead and verify that. It starts from the start, and thereafter it goes to the agent. Agent decide it need to call the tool. Tool is called. Tool returns the retrieved document to the agent, and then the agent gets the answer. Thereafter, agent again check whether it need to call the tool. Then it decide that no, I have got the answer. Then it goes to the end. So this is the beauty of the Langsmith. You can observe each and every step of your agent, and then you can decide that where you need to. Basically, if you need to fix anything, then you can decide that where you need to fix and what you need to fix. So this is how you can get the response from your agent. Now, let's go ahead and implement our whole method, where we will be implementing a method where we will be passing a question and then it will be returning the answer. So I define a method that is going to accept my a question, basically my question. And this is like just a small doc string. And here I'm just going to print my question, and a little bit formatting is being done here. Thereafter, I'm going to call my agent into a stream mode. Basically, as it produces the answer, it is going to be printed here. And in stream mode, I have here messages, and in that I pass the role user, and there is the content. So basically, this is going to be my question. Otherwise, I can just simply pass here as a question directly, like I had used previously. Thereafter, it is going to take the last message. Now, the question is why last message? Because I don't want every message. As you see here in this section, we hired a query. That query goes to the agent, and then agent calls tools and agent process. There are so many processes happening there. But the final answer is always the last message. So that is why we are going to read and we are going to take only the last message. So we take the last message. Once we get the last message, thereafter we are going to check there if there is any tool call. All right, so it check that if there is any tool call in the messages. All right, so it check that okay, if there is a tool, then I'll say that okay, this particular tool I'm going to use. All right, so basically this is the information which will be printed just to let us know that these particular tools are being called. And thereafter, finally, we are going to get the final content here. All right, so we get the final content that it is going to tell that what particular tool is called and what AI thinks, and finally, what is the final answer or final inference from the AI. Once all these things are done, let's go ahead and just simply run this. Let's go ahead and test our ask method. So we can just simply test our ask method with a simple question that we are going to ask here. What are the main method mentioned in this paper? So I'm just going to execute. This is my question here. Now the answer is going to be calculated for this particular question. What are the main method mentioned in the paper? And then it says that I'm using a tool that is retrieve context with this particular query. And then it is searching, it found 4 relevant chunk. Thereafter, all these data goes to the LLM, and then LLM produces here the final answer. LLM says that, okay, so these are the answer, page 103, method this one mentioned, all right, GSM8K, etc., zero sort, standard prompting, chain of thought method, then it has a least to most, and there are so many things, all right. So as we see here in the uh, as we see this with the scroll method, so these detail what you see here, these are coming from your tool, and then finally your LM is producing final answer here. And your LM says that the paper mentions several key method across different contexts. Here is the structured summary. So these are the method on the page 103 mentioned prompting strategy. Decomposed prompting is mentioned on the page 4. In context learning is mentioned on the page 83, and the LLM fundamental is mentioned on the page 4. All these things, as you see how good your agent is working here. Your agent is working perfectly good and it is super easy to implement. Right. So this is how you can test this. Let's go ahead and run this into, run this into the interactive chat mode. So to run it into interactive chat mode, I'm going to implement here a method define chat. Thereafter, I'm going to make here while true so that it can run forever. And then I'm going to create, I'm going to accept my, I'm going to accept my query into the question. Thereafter, I decide that if so, this input is going to come from the user. And then I decide that if I write quit, exit, or queue, then exit. Otherwise, pass that to my ask method. So, ask method is here. All right. So, to this method, it is going to pass to the ask method, and then ask method is going to ask method is going to invoke our agent. And then here is the chat. All right. Perfect. Let's go ahead and run this and then see what happened here. Perfect. Let's go ahead and pass here answer. I say that what are methods of RAG, right? Let's go ahead and run this. I hit the enter. Now this is passed to the ask method. Ask method is calling the tool. It returns here a 4 relevant chunk, and this is the answer from the tool. Let's go ahead and see into the scrollable mode, and here your LM is producing the answer. Let's go ahead and type here a Q so that we can just stop this. Now it is stopped. Here, as you notice, so I asked that what are the methods for the RAG. It says that the method for RAG involve integrated retrieval system with the language model to enhance generation quality. The key method include like the dense retrieval, sparse retrieval, hybrid approach. Then the modular RAG architecture we have like the search module, RAG fusion. Interactive retrieval generation framework we have self RAG, graph tool, web GPT, and then we have evaluation metrics, all these things. You see here that your result is grounded. Basically, your answer is grounded here. We had provided a document here, as you know that previously, I guess I had shown you. So somewhere I must be having, seems like that is gone, but I can find out from the previous notebook. So at the start of this lesson, I mean the previous lesson, I had provided you link which I used to ingest my data. Yeah, here, this one. All right, so this is the PDF document which I used to ingest the data. Here it comes. So it is the survey on large language model with some insights on their capabilities and the limitations. So this particular research paper is working as a ground truth for my LM. As you see, whatever question we have asked here, all the answer is grounded to our LM. It has produced that with a proper reference that from which particular page it is actually extracting the answer. All right, perfect. Now I hope that this was helpful to you and it is going to help you to make a good RAG project with the latest library from the Langchain. All right. If you have liked this lecture, if you have liked this lesson, please do not forget to like this video and subscribe this channel. Bye bye. Take care.